Now we will study physical and chemical changes. The difference, along with the difference, we will study the two types of changes and examples I will show you. In a physical change, no new substances form. The molecules, they retain their identity and the properties. No change in the molecules, structure of the molecules, and no change in the properties of the molecules also. They retain their identity. For example, suppose, as I was saying, we will explain this with the help of ice melting and with the candle burning. Melting of wax is a physical change, but burning of candle is not. So actually burning of candle is a combination of physical and chemical changes. Look at this melting ice. What happens when the ice melts? Does the water molecules change? No, they don't. It is just solid ice and water. H2O, solid is ice, this is ice, and this is converting into H2O, liquid, that is water. So the properties, the molecules are same, their properties are also the same. They do not change. It's just a change of state or change of color or change of the physical properties only. Chemical properties of the matter does not change in a physical change. It's a temporary change. As the ice is changing to water, the water can again be frozen back to ice. So it's a temporary. It can be converted back to ice again. Similarly, if water is boiling and converting into steam, that also can be reversed back by condensation and it can come back to its original form. So it is a temporary change. It's not a permanent change. Next is the change can be reversed by physical methods. That means on freezing, it turns to ice, and on cooling, it turns to water. So by physical methods like freezing, condensation, sublimation, these changes can be reversed back. Then finally, no net change in energy takes place. Although when we are cooling it, then we are getting ice, and when the ice is heated, it absorbs heat and turns into liquid. But the net amount of energy that is absorbed for converting into water is again given out when it is changing into ice. So on the whole, there is no change in energy that takes place. Mass also remains the same. That means suppose you have taken 30 grams of ice over here and that melts. When it goes to the water state, it will also weigh 30 grams. And again, if you re-solidify it, if you change it into ice again, it will remain the same 30 grams. So the mass of the matter does not change. Next, we will see the same thing we will study now with chemical change. What is chemical change? With the help of the candle burning. The candle is burning. If we had weighed this candle before we light it, and we weigh it at the end, we will see that there is a change. Means after this whole candle will burn off, the mass definitely will decrease. Okay. But first of all, let us see the chemical composition of the matter changes. As I said, this is partly physical change and partly a chemical change. Where the wax is melting and here the wax is collecting down at the bottom, we can see. So the wax, melting of wax is just solid wax to liquid wax, and again it converts, re-solidifies back into the wax. That part is physical change. But the burning of candles, some of the candle turns into, this is a hydrocarbon. Candle is a hydrocarbon means a compound made up of carbon and hydrogen. So when a hydrocarbon burns, then always the products are carbon dioxide and water. So when the carbon is burned, when this candle is burning, the wick is burning over here and it is converting into carbon, and the hydrocarbon part, CXHY suppose, CXHY, this is the candle burning. There is no fixed number of hydrogen and carbon. This burns, this plus O2, it is burning in presence of oxygen. So this plus O2, what are the two? Whenever a hydrocarbon burns, the product is CO2 and H2O. So those two, CO2 and H2O, they are liberated in the atmosphere, they go back to the atmosphere, and the molten wax, which is a physical form, some of the wax melts and again resolidifies in the form of wax. The change is permanent. Once it is done, once it burns off, then you cannot get back the candle. You can get back a little bit of the wax, of course, but the wick inside has burnt, and this change converting into CO2 and H2O, this is a permanent change. Other examples, see, rusting. Fresh piece of iron I have taken, and the same thing on rusting, that is iron oxide is formed. It's also a permanent change. And then let us see other change. So permanent change, just now we discussed this, it cannot be reversed. It's a permanent change, it cannot be reversed. You cannot get back the candle once it has burnt off. Heat or light or both, there are energy changes, means heat is liberated or light is liberated, or both. In this case, both are liberated. You can see the light energy, you can see the heat. If you hold your hand on top, you can feel the heat also. So both here the energy change is taking place. And apparently there is a mass change, although you might think that this is a violation of the conservation of love. In the last class, conservation of mass, sorry. In the last class only we had, when we were doing matter, I had told you that matter can neither be created nor be destroyed. So if we are saying that the mass is changing, actually what you see here is, that's why I have written the word apparently. The mass changes, but actually if the experiment is done in a closed atmosphere, then we will see that the mass has not changed. The total mass, what was at the beginning, if we add all this CO2, H2O, molten wax, etc., it will be the same. Now let us perform some more experiments and see a physical and a chemical change. This is sulfur powder, and this is iron particles. Now they have specific properties. These, if I mix this sulfur and iron particles in this, this becomes a mixture. And this is not a chemical change, this is a physical change. Till now it is a physical change. Here the mixture retains the properties of both sulfur and iron. But if I heat this for some time, what are the properties of iron and sulfur? Let us see this with this help of this mixture. Let us do this experiment. Here's the mixture. Now in this, if I want to separate the iron is attracted to the magnet. So if we have to separate the iron from the mixture, then what will I do? I'll just take a magnet near it, and you can see that all the iron sticking to it. In this way, all the iron will be sticking to it, and the sulfur particles remain over here. That means the iron has retained its properties, its identity, and it is getting attracted to the magnet. Now what is the property of this sulfur? Sulfur's property is that it gets dissolved in carbon disulfide. So I'll take a little bit of sulfur in this. And I'll try, this is carbon disulfide, I try to dissolve this in this. See, sulfur dissolves in carbon disulfide. Now I'll take the mixture and I'll try to if I take the mixture and dissolve it in this carbon disulfide, then we see that the iron settles down and the carbon disulfide dissolves. That means the carbon disulfide retains its property. Now we heat this mixture. This mixture of iron and sulfur, we will heat. So that was all a physical change. Physical change means it has the particles do not lose their identity, no new substance is formed. It is just a mixture of iron and sulfur in the proportion that it had. No fixed proportion, any proportion that it was mixed. Now if I heat this, there was no energy change involved in this mixture. I did not heat it or I did not cool it also. So there was no energy change in that. But if it is heated, then we will see that the compound FeS is formed. Fe plus S is FeS, that is iron sulfide is formed. And iron sulfide has a property totally different from that of iron or sulfur. Iron sulfide, now this will take some time, I have kept over here one iron sulfide, you can see. This is the iron sulfide. Now if I take this, this is a new compound formed. This is a totally a new compound formed. So here the chemical composition of matter changes and a new compound is formed. This, if we take the example of Fe and S, and we have supplied energy to it, on heating it turns to FeS.